Hi, welcome to our lecture on annuities and perpetuities. My name is Tim Howell. I'm the CFO of a company, and I hold both the CFA and the CPA designations, and I use this math almost every day in my job. So with that, let's move forward. Annuities and perpetuities. Annuities and perpetuities really describe a series of constant cash flows which occur for some fixed number of periods. That is called an annuity. If the constant cash flows continue forever, it's called a perpetuity. So let's look at this. C is your constant cash flow. Let's say someone was going to promise to give me $100 a year every year on a year from now. So that would be our C. Our $100 would be our C. And every period would be our year. And our discount rate, or the rate of return, would be, say, maybe we might call it an interest rate or something like that. This would be sort of a percentage here. So to calculate, and remember our discussion of present value, the present value of the first cash flow, the $100 I'm going to get in a year, would be the $100 divided by 1 plus the rate of return. So that's the cash flow from a year from now. Then the cash flow 2 years from now that I would receive, again, same $100, same rate of return here, same R, but then we'd raise that to the power of 2 in the second year. And then of course you add that to the first one. Then in the third period, same calculation, you're just raising it to the power of 3, and so on and so forth. Well, obviously a perpetuity would go on infinitely, and we won't want to add everything up like this, but algebraically it's going to convert to this, the C, the amount of the cash flow, simply divided by the rate of return. So in our case it would be $100 divided by, I'll pick one, say 6%, and that's what it would calculate to be the present value. So here we have the formula for a present value. Now I want to remind you that in most cases you'll simply use your financial calculator to come up with the values here. Let's understand what the terms are here. The C is the periodic cash flow, the R is the rate, and then here we have the N is the number of periods. So let's walk through a simple example of an annuity. Calculating the present value today of $500 that I'm going to receive in year 1, year 2, and year 3. So essentially someone's promised to pay me $500 a year for the next 3 years, and I want to know how much that stream of payments is worth today. So using our formula, we would take the 500 and we were going to divide that by 1.10, that's the discount rate here, and that 500 divided by 1.10 is 454.55, and in year 2 we want to divide by 1.1, again using that taken to the power of 2. So again, over here, 500 divided by 1.1, power of 2 is 413.22. And then in year 3, same, just continuing on to the power of 3. Is 375.66. And you notice how as the time goes out, the amounts that they're valued today is less and less, which makes sense when you think about the time value of money. The sum of those three numbers, 1243.43. Okay? So that's a simple way of doing it individually. However, then we can use our formula though for the total. So we'd go 500 divided by 1.10, again our discount rate, and then take that 1 minus 1 over 1.1 to the power of 3, and then that again would come out to the exact same number here. So let's walk through another example of an annuity, and actually this would be the annuity where we are actually having to pay. So this is actually like somewhat of an example, sort of like a car payment or something like that. We have to pay $500 a month for the next 60 months, and the discount rate is 0.7% monthly. Remember, because we are paying monthly. So what's the present value of these payments? So we would be the 500, they're negative, I'm going to use brackets there, and the discount rate is 0.007. 1 minus 1 over 1.007 to the 60th power. Okay? And what that comes out to be is, this is 1 minus 0.065801. And this division right here is minus 71, 428, 57. Bracket that, and that is 24, 427, 86 is the present value of that. Now, when cash flows come at different times and they are not uniform, and when the rates of return vary over the periods, that creates different challenges in calculating a total return for the period. So we might look at money-weighted returns or time-weighted returns. So a very, very common measure in finance is the internal rate of return. That's the money-weighted return. And the internal rate of return is equal to the rate of return that satisfies the following formula. When cash inflows discounted at that internal rate of return are precisely equal to the cash outflows discounted at the internal rate of return. When those two, when you find the number that make the cash inflows and the cash outflows discounted the same, that is the internal rate of return. All right, so for any given set of cash flows, the internal rate of return can be found using your financial calculator that you're going to use during the exam. So in the next slides, we're going to do an example to show you how to work that problem. So let's walk through an example of an IRR calculation. In this table, we're going to describe some of the cash flows of a hypothetical investment. In quarter one, the balance started at $50,000 and our investor contributed $25,000. The investment itself had a return of $15,000. Then in the next quarter, we started with a balance of the $90,000. Our investor made another contribution for $10,000, and unfortunately, the return on the investment was a negative $20,000, leaving us a beginning balance at quarter three of $80,000. Our investor did withdraw $5,000 here, but the investment returned $25,000, leaving us a balance at the beginning of quarter four of $100,000. Our investor took out $20,000, and the investment returned $16,000. And then at the very end of quarter four, our investor withdrew his whole balance of $96,000. All right, so this slide summarizes our investor's cash flows. He began with $50,000, added another $25,000 to his investment, added $10,000 to his investment in quarter one, withdrew $5,000 in quarter two, withdrew $20,000 in quarter three, and withdrew the final $96,000 of his balance in quarter four. So if you would input these cash flows into your financial calculator, you'd end up with an internal rate of return of 10.2297%. Now, we're going to talk about the time-weighted return on this slide, and these are the multiple growth factors for each sub-period, each quarter in our previous example. So, for example here, he contributed his $50,000 and $25,000, the investment returned $15,000, and you divide that by his original investments here to give you a rate of return for that sub-period of 1.2. In quarter two, we had the beginning balance plus the 10 he put in minus the 20 the investment loss, again divided by the original balance to give us 0.8. Continuing on into quarter three, $80K minus the $5K he withdrew plus the $25K the investment returned divided by the 80K minus the 5K, here the original balance, for 1.33. And then at the end, 100K minus the 20 he withdrew, plus the 16K the investment returned, again divided by the 100K minus 20 for another 1.2. So let's calculate the total growth factor from our prior example. So for the 4 quarters, 1.2 times 0.8 times 1.333 times 1.2 gives us 1.5360. To get the time weighted return, we simply take that number minus 1, and that equals 53.60% for the entire period. To weight that return by quarter, we take that 1.5360 to the power of 1 quarter minus 1 gives us 11.33%. Now recall that our IRR was approximately 10.2%. So you can see that the time-weighted return was a little bit higher than the internal rate of return. And why is that? Well, that's because the time-weighted return doesn't really capture the amount of money invested in any given quarter. So while the investor had a very strong return in this 3rd quarter here, he didn't have as much at work. The IRR actually captures these differences in the amount invested at any given time.